Hello everybody, so today I will do the system design of Tinder. So I will start with the function requirements. So Tinder is the kind of obviously the most famous dating app, and the user can create a profile with his profile pictures, and also he can, specify the interest or profile, introduction text, and also he can specify what kind of partner he'd like to meet or she'd like to meet, like the height or maybe I don't know, nationality, race, or something like that. Yeah, and also what is unique in Tinder is it has the geolocational limitation. I mean search. So let's say I'm in Los Angeles, and if I'd like to meet someone in Los Angeles, I can set the distance to be up to, let's say, 10 miles or maybe 20 miles. So yeah, and my location is updated periodically in Tinder when I log into the Tinder, or when I'm opening the app. Yeah. So those are the functionalities of Tinder. So I will write it down. So firstly, of course, we need the profile for each user. The user can create a profile and specify the preference. Yeah, for the people whom he or she would like to meet, and specify and max distance. User can create a profile and specify the preference, including maximum distance. Okay. And let's think of the matching. So I can see the profiles of other users in the Tinder. And typically, the number of users I can scroll, or should say swipe, right or left, is limited. Of course, in some cases, like if I subscribe to the premium membership, it can be unlimited, but typically it's limited. I will write it down. User can see the stack of potential matches users in a day. User can see the stack of users, and okay, in line with preference and distance. Yeah. So of course, those users in the tag should align. Should satisfy the preference and distance condition. And as I said, users should be able to swipe those users. Right or left. So when I swipe right, it means right or left. Skip. Swipe wrong. Okay, and of course both of them swipe right to each other is a match. So user matches the other user when they swipe right each other. Okay. And I will include one more thing quickly. So user should be able to start the chat. So of course this is Tinder should typically have this functionality. I mean the chatting, but I will include it in this, design. Until yesterday I posted a video about WhatsApp, the messaging app. So for this Tinder, I will focus on the matching functionality. But let's add this one. User can see the list of matches. Okay, so these are the function requirements. Now I will talk about the non-function requirements. So I will start about the discussion of cap theorem. So cap theorem is consistency, strong consistency, and availability and precision tolerance. So the system can meet two of three. I have to give up one of them. So because we're developing the distributed system, the partition tolerance is a must. So without partition tolerance, when there is a network loss, disconnection between towers, the system cannot control it, cannot know. The system doesn't know how to handle it. Of course, this is not acceptable. So I need the partition tolerance. So with that being said, I have to choose from availability or strong consistency. So this I can rephrase this like this. So user has to be able to read the latest data. And latest data means the latest write onto the data. And if I'd like to guarantee this, it means that we need a strong consistency, so availability is not guaranteed. But if I take the availability, it means that the system returns the result data, but the system always returns the data, but it may be outdated. It may not include the latest update on that data. So that's something, there's a discussion about strong consistency versus availability. And here, I will choose the strong consistency for matching. And availability for other features. I will explain what this means. So when I think of the match, I need the strong consistency because let's say there's a user who makes a right swipe to other user, and there is another user at the next moment tries to swipes the first user with the like swipe. In this case, they should match. However, let's say there is a match data, write data from A to B, and there's another write data from B to A. So both of them are created, but let's say there is a kind of matching process, matching service, which reads those data. And it is possible that it cannot read the latest data from A to B and reads the right data only from B to A. In this case, it overlooks the match. Yeah. So to avoid this overlook of the matches, I need the strong consistency for match. And for others, let's say like the profile page rendering or something like that, eventual consistency is good enough. So it is completely acceptable that I open the user's profiles page and that user just updated the profile, but I see the bit outdated data. It's okay. And even with that, I'd like to, always read the profile of that user. So I accept the availability here. Okay. So next I will talk about the latency. So I choose the number 500 millisecond. So this number is for the creating the profile and submit, then the submit submitted profile should be rendered in the front end within 500 millisecond, or when user opens the app and the stack of users appears and the first profile appears, it should be less than 500 millisecond. And also swipe right, swipe left. Yeah, definitely it should be quickly done, and he can continue swiping without waiting for it. And yeah, of course, yeah, the fetching the list of matches, that should be done within 500 millisecond. And oh wait, yeah, let me just add something to the function requirement. So I said there should be a match when user matches another user when they swipe right each other. And I will be more specific on this. So when user swipes right, and if he matches, then I'd like to show the user immediate kind of UI that notifies him that it was a match. This quick reaction, where I should say feedback, is very important, I think. And also, when the match appears for the other user who is swiped right now, he or she should get the notification. So I would say each other and user can match with application UI or push notification. Okay. And I come back to the non-function requirement and I add the scalability. So I would say scalable to 20 million daily active users. Yeah, okay. So that being said, let me go to the core entities part. The core entities are like the table names of the database. So I will clarify which kind of models I need in this design. I will talk about the attribute of each model later when necessary. So of course we need the user and location and profile and what else? Maybe stack. So this is actually, this stack is a kind of users accumulation of the users. So maybe I don't need it, or maybe need it. But sorry, profile, let me delete it, and I can think of the profile as the attribute of the user. So I delete it. And also we need swipe. So swipe has two types, like or skip. Okay, and maybe match. Again, so this match is a kind of dual swipe. So yeah, but because after they match, there should be the chat room created for those matches. So yeah, I think it worth creating the model named match here. Okay, so now I move on to the API design. So I will list the names of APIs according to the functional requirement. So of course we need create, or I should say update profile API. I don't talk about the user sign up here in this discussion. So user needs to update profile, and yeah, including max distance, yes. And also because we need the discussion of the distance, we need the API for the client to update the current location of that user. So I would say update location API. And when I take a look at the second function requirement. User can see the stack of users in rhyme, its preference and distance. Okay, we need get stack API. Then when I take a look at this, user can swipe right or left. Yeah, of course we need swipe API. Then about the matching, I'm pretty sure that I don't need the matching API. So when user swipes, this should return the match if they match. And of course, as a side effect, we need the push notification here. Anyway, I come back to the function requirement. User can know the match with the UI and the push notification. User can see the list of matches. Yeah. So we need get matches API. So now I will, talk the detail of each API. So for this one, update profile API, we use I think there are two approaches here. The first one is using the post API, and the other is using the put API. The post is, which is the put, is kind of replacing the whole data. So when I use the put API, we have to, the front end includes all the profile data and updated the whole, profile. So sends the whole updated profile data and server side updates the database. But for post API, what happens is that the front end specifies only the updated attribute, and then backend update only that attribute in the, let's say, database. And when I compare this, I would go with the post. Sorry, this is not post. This should be patch API. So patches, yeah, literally, this API updates a specific attribute in the data model, like user profile data's name only. It can be updated with patch. And when I compare this, I'd go with the patch because I think it is better that when user update a specific profile attribute, that should be immediately updated rather than waiting for user to wait. Sorry, rather than waiting for the user to finish updating all the attribute in the profile update page. And the reason is, yeah, it is possible that after updating the wrong text of the profile description, the app goes, sorry, after it is done, user tries to update other attribute too, and then in the moment, the app goes down. In that case, the wrong text description he wrote will be lost. So rather than updating all of them, I would rather update only the specific attribute one by one. So I can use patch here. And of course, patch API doesn't have to send, or I should say, request body size of the patch is definitely smaller. So I will go with patch. The patch users. So of course, this service needs the authentication. So I will include the session token in the header. And with this, our server side can know which user ID, which user made this request. So I can just need profile. Yeah, this is good. And as the request body, we include, let's say, description, something. Maybe we include the preference raised or preferred height. Yeah, one of these is specified. Okay. And this returns 200. Yeah, of course we can use in the front end, we can use the optimistic upload. So when this API, when users finish the input, the front end can just show the updated attribute. And if this API returns a failure status, we can roll back the UI to the original one and just show the pop-up like the update failed or something. Okay, so update location API. The reason why I separate this API from the first one is this location should be periodically sent to the server side without user making any actions. So I use the put API here. I can replace the data of the current location with the data which is sent by this API. So this should then latitude and longitude. And this should return 200 success status when it succeeds. Okay, and get stack API. So I can do something like this. So this returns the user's profile, list of the user profile. Okay. Or I can replace stack. And swipe API, so this should be, I would use put API. So let's say post. So this created a new swipe record. So I use post. And of course, I need the Boolean, which clarifies if this is the right swipe or skip swipe. With this, this returns 200 status, which is 204, and maybe this returns match. Yeah, if it matches. Okay. Yeah. Maybe just Boolean is fine, because all the front end has to do is showing the pop-up, UI, and after that, probably he should be moving to the chat room. So in the chat room, necessary data should be rendered. At this moment, as a response of the swipe API, just a Boolean is enough. Okay, Rust get matches. So for this get match API, front end should return the list of matches. Okay, so this is it. I just noticed that I missed something important here. For this swipe API, of course, we need the user ID who is swiped. So I'll say target user ID, and then it's like Boolean. Okay. Now I will do the high-level design. So I will take a look at each API and try to implement this. So in this design, I will go with the microservice design. Um, I can list so many reasons, like um, of course, separation by the domain. I try to separate each service to with the domain, so that the inter-domain interaction can be clarified with the API call, and also we can, and with this, the each team's forecast becomes clear. So each team should focus on the specific microservice, and also I can say first this is for the availability too, because even if, let's say, swiping feature fails and goes down, I'd like to I'd like the messaging service to keep working. So I separate the servers, microservices, so that some of them should keep working, regardless of others failing. Yeah. So here is user, and user makes a request. I will go with update profile API. So there is the API gateway. So there should be authentication, routing, and rate limiting. And user makes a request to update profile. So I put the profile API here. So profile service here. So the request is routed into the service, and this saves the data in the profile DB. So here we need user, yeah, like gender, height, and also preferred gender, preferred height. Yeah, and also max distance and some other fields. So basically the profile data and preference data. Okay, and this service creates or updates the data in this DB. So this is it. And for the database direction, let's go with the PostgreSQL first. So far, I don't have specific reason to use other database. Yeah. Okay. And next one is update location API. So this is a kind of background API call. So, and I can say this location service location update API is quite heavy loaded for server, because each client makes a request, let's say every 3 minutes or something. So I separate the API for the reason I just mentioned. I want other service to be keep working, even if location service goes down because it's a heavy load. So this updates the location service, and this updates the DB. Okay. So this location service updates the location DB. That's it. Okay, and for this DB, I would use. So this is right intensive. So I think I can use Cassandra. But to be honest, I'm still not pretty sure how much heavy loaded this server is. Yeah. So I just want to use Cassandra here. And just to be clear, when user, when creating the stack of the user, we have to filter the user's other user's location by that user's current location and location preference. So, but obviously Cassandra is not built for that purpose. Okay, so I'd use the PostgreSQL because PostgreSQL has the okay, so but yeah, thinking of the high intense, yeah, the writing is quite intensive on this location DB. I will use the Redis. Sorry, I've changed my mind. So I store only the location, latitude, and longitude in this Redis, and Redis supports the geolocation in data. So Redis geolocation DB, index uses geohash internally. So geohash looks like this. So each cell is divided into four spaces, four cells, and that division occurs recursively. And this kind of hash value, 000, 001, can be stored in the database, and the database can create the B-tree index result. So with this, let's say I'd like to search the area around here. The area inside of 122. So in this case, and let's say each cell is 10 kilometer, and I'm looking for the max distance 10 kilometer here. In that case, I will take a look at three cells here, these cells here, and I get the, how should I say? So I take a look at each point and calculate the distance from the center point and check if it is less than 10 kilometers. Of course, it is not enough to take a look at this only one cell because of the boundary problem. So let's say the center point is here. In that case, the center point is in 122 and very close to 120 cell. In that case, of course, I have to take a look at 120 cell too. And the similar thing happens for all these 8 surrounding cells. So yeah, I use Redis, and internally it uses geohash. Yeah, and I also quickly mentioned about the boundary problem of the geohash and how the search should work. Of course, this search handling, the search logic handling the boundary problem is implemented in the Redis, so I don't have to take care of that. But yeah, I use Redis. Of course, Redis has the problem that this is not durable compared with PostgreSQL, but the location data is updated, let's say every 1 minute or something. So even if some data is lost, we can get the same data. The data for the same user after 1 minute. So I think Redis is fine. Rather, I want the low latency for the update here. So now this Redis has the latitude and longitude data, and let's update that. Okay. So this is how update location API works. Oh, of course, I can use, let's say, Elasticsearch for the geo, location search, and Also, I can use, as I said, PostgreSQL point index, point data type. Yeah, PostgreSQL natively supports distance-based search actually. So I think it is another option that I put latitude and longitude here, but I didn't do that because if I do this, this profile DB, is quite heavy loaded because of this update queries. Yeah, so rather I separate this. Yeah, so that's how I design. Okay, next get stack API. So for this one, I create another server which returns the stack of the profiles. But here I'd like to call out that this stack creation takes so much time. So if I'd like to create the stack, what I have to do is firstly filter the users who are in the same who are in the maximum distance for that user, and then also I have to filter the appropriate users by the user's attribute, and then I have to take the intersection of these two list, user ID list, and return it. But I can easily imagine that this is quite heavy loaded, so what I can do is instead I do pre-calculate the list of users in the stack. So I create the stack DB. So for this one, I can think of this as user ID to the and I will call it stack user. So this is the kind of relation table. So stack user means user ID and stack user ID. Or I should say suggested user ID. Yeah. So for user A, if user B and C should be suggested, two records are created. User B's suggested user ID is B, and those users suggested user ID is C. So now this stack service fetches data from this one. And here I'm thinking of using the DynamoDB because for this stack user, I don't need the join query, and I'd like to, obviously I can do the partition with user ID because I can treat the suggested users for each user to be completely independent. And when it is completely independent, I can use user ID as the partition key. And the thing is, I should say, so yeah, because DynamoDB internally scales out the database, it does a kind of sharding with consistent hashing internally. So it is completely possible that I use the PostgreSQL here, but in that case, I have to do the sharding by myself in the application logic. So this is a small difference, but for this scalability without custom logic, I choose the DynamoDB here. And I, sort the users. Yeah. Because partition key sort key combination has to be unique, I would choose the suggested user ID here as a sort key. Created that. Okay. And of course, I can set the TTL because let's say we calculate the stack every day. So let's say every night as a daily job. So I can set TTL to clean the outdated stack user. Yeah, of course, this is another reason that I wanna use DynamoDB here. So now I add the daily job. So I'd say stack creator generator job. This is the daily cron job. So this fetches the user's preference data, and also this, as I said, searches the user IDs in the specific, area from that user's suggested user's distance, center current location plus max distance. So I get the list of those users and merge them. Sorry, takes the intersection and update this one. Okay, so this is it. Yeah. So this. Okay. Now I will talk about the swipe API. So I create another database here. So when user swipes the user, yep, the request is routed into this swipe service, and it creates the swipe record. So user ID and swipe at. So this record is created. And the reason why I create the swipe DB separate is the same reason with location DB, because write query is quite intensive. So I don't create the swipe record table in the PostgreSQL. And that being said, when swipe record is created, it has to check if it is a match. So first we create a record in swipe DB and then checks the sorry. So first we create the swipe record and then checks the match. So this is it. Yeah. And of course, I didn't mention about the strong consistency yet. So if there are two users who create the swipe record at the same time, it is possible that the race condition happens and we miss the match. But here, so we create the match record. User one. Let me make it here. So when this match record is created, we need to notify the user. So what I can use here is use the change data capture. And this match notification service hits the third-party API, right? Google's Firebase. Where was it? Let me check. So Firebase messaging API or Apple push notification service. So these are hit, and then this sends a notification to other user, matched user. Okay, so this is it. So I think this is a higher level design. Oh, and I need, of course, I need the get matches API. So matches here, just in case I separate the server. Because as I said, Swipe service has a completely different, access pattern of the traffic. So this fetches the matches and return it to the user, and yeah, user can know the list of matches. Okay. Oh, for this swipe DB, I would use the PostgreSQL. I think I will talk about this in the next video, but we need the strong consistency here, and the best way, maybe not the best way, one of the ways to do the guarantee the strong consistency and avoid race condition is to use the PostgreSQL, or I should say relational database transaction. So I use the PostgreSQL. But of course, from the write throughput, I have to consider if this can handle it, or maybe I need the sharding. So those things I will do in the next video. Okay, so that's it. Yeah, so I finished this high level design. I will talk about the non-function requirement like strong consistency, low latency, scalability tomorrow. Thank you so much. Bye.